Imagine stepping into a dimly lit study in 19th century, where a young mathematician named Emmy Noether sits surrounded by stacks of papers, scribbling furiously on her chalkboard. Her work, obscure at first glance, would soon revolutionize algebra and fundamentally reshape the very way we understand symmetry in mathematics and physics. Today, I want to take you on a journey through the captivating world of abstract algebra, highlighting Emmy's trailblazing contributions to the stunning structure known as Noetherian rings, concept that forms the backbone of modern algebraic geometry and commutative algebra. Abstract algebra often seems like a jungle of strange symbols and axioms, but beneath the surface lies a universe of breathtaking order and beauty. Let's start with a deceptively simple question. How do we control or tame infinitely complicated algebraic structures? When can we say that a ring, algebraic system where we can add and multiply, behaves in a manageable? Emmy's genius was to formalize this intuition through what she called the ascending chain condition, all of my. Now the hallmark of Noetherian ring. Picture a scenario. You have an infinite sequence of ideals inside a ring, and these ideals are nested, each inside the next. Meanwhile, unruly rings is seem to grow endlessly without settling down. But in a Noetherian ring, Emmy's defining property guarantees that after some finite step, the chain stabilizes. It stops growing any further. This idea may seem technical, but it has profound consequences. It allows us to decompose algebraic objects into simpler, more digestible parts, just like a complicated molecule can be broken down into atoms. Why does this matter beyond pure math? Noether's work transcended algebra and entered the realm of physics, particularly through Noether's theorem, which links symmetries in nature to conservation laws like energy or momentum conservation. This fundamental bridge between algebra and physics underscores how studying abstract algebra's subtle structures can unveil the secrets of the universe itself. Back to Emmy's story, she faced extraordinary adversity as a woman in the male-dominated academia. Initially, not even permitted to officially enroll in the university. Yet, her perseverance and intellect shattered those barriers. The tools she forged, such as modules of rings, chain conditions, and ideals, became cornerstones for algebraists and geometers alike. As graduate students point at the age of deep mathematical exploration, consider this: Noetherian rings are not mere definitions in a textbook. They encapsulate the philosophy of control and structure in infinite systems. Working with these rings enables you to navigate infinite algebraic landscapes with confidence. But a true adventure starts when you begin to ask, what happens if we relax some axioms or extend these ideas to non-commutative rings? How far can Emmy's notion stretch, and what hidden patterns will emerge? So I invite you to dive into Noetherian rings, not just as abstract entities, but as living concepts that connect algebra, geometry, and physics. Let yourself be inspired by Emmy Noether's legacy, her courage, creativity, and groundbreaking insights. In doing so, you step into a tradition where deep abstraction meets profound truth, and where your own discoveries might one day illuminate the complexity of our mathematical cosmos.